Welcome back to my YouTube channel, and today we are doing 0620/12 past papers of May-June 2019, which is the most recent one. And here I am recording the second part for you all. I hope you have checked out the first part. If you haven't, I'll drop the link in the description box below. So in the first part we did MCQs 1 to 10 and it was still here. Now I'm gonna start up with the 11th one, that is on page number 5. Which row describes the energy level diagram and the energy change in exothermic reaction? First of all, as I told you in the previous video, make sure you check it out. I told you to mark out the key points. So here the key point would be energy level diagram and energy change in an exothermic reaction. So if you look at the exothermic reaction, so reactants are always higher than the products and never lower than products. Because it's an exothermic reaction, that means heat is released out, so reactants have higher energy in this way. So that is why reactants have higher energy than products, are higher in energy than products. And energy is always released when we talk about exothermic reaction, thus products have lower energy. So the answer is gonna be B, because here it is reactants higher than products and energy is released. Coming to question number 12, which process is a physical change? So for physical change, we are looking at no chemical changes, that means no permanent changes. So when a firework is exploded, so we cannot bring it back, it's exploded. It cannot come back to its original form. When we are burning wood, once wood is burned, it releases gases and ash, and this is not reversible. So it's once again not a chemical change. In fact, there are a few chemical changes that are actually reversible. So we're not going into reversible and irreversible reactions in depth right now, but we are just going according to the question that what could be the physical change, what does not have any burning or such things in it. So it's gonna be physical. Iron rusting is once again a chemical change and not a physical change. However, chocolate melting is a physical change, so it's gonna be C. Question number 13, an experiment is set up as shown. The mass of a conical flask and its content is measured at 30 seconds interval. This statement about the reaction and about changes to the reaction conditions is correct. So here you were supposed to look at the setup, and we're gonna read all the options. Adding 10 centimeter cube. First of all, I'll give you a bit of an overview about this question. Mass of the conical flask and its contents are measured at 30 seconds interval, which is, you can say, a sort of a key point. And balance, and this is 1 gram of calcium carbonate and 50 centimeter cube of dilute hydrochloric acid. The statement about the reaction and about the changes to the reaction is correct. So for this, we are gonna see adding 10 centimeter cube of water to the 50 centimeter cube of acid increases the rate of reaction, which is not correct. It dilutes the solution, so it doesn't increase the rate of reaction. Increasing the size of the pieces of calcium carbonate increases the rate of reaction. No, that is completely incorrect, because this is not possible. If we decrease the size of calcium carbonate by any ways, by crushing it or breaking it, then it can increase the rate of reaction. However, this cannot increase the rate of reaction bigger particles. Coming to C option, increasing the temperature increases the rate of reaction. Yes, increasing the temperature does increase the rate of reaction, and this is right. The mass of the conical flask increases as carbon dioxide is formed. No, it always decreases, because it's a gas which is going to be released out, and you can see it's not a closed system, it's not a closed container. When blue-green crystals of nickel 3 sulfate are heated, water is produced and when blue-green crystals of nickel 2 sulfate are heated, water is produced and a yellow solid remains. When water is added to the yellow solid, the blue-green color returns, which describes these changes. So this here we're talking about nickel 3 sulfate, which is heated. It's blue and green in color, and then after adding water, water is produced after heating it, and then a yellow solid remains. When water is added to the yellow solid, the blue-green color returns. Okay, so it's first of all something that is okay. By reading the statement, this thing clicks in our mind that it's a reversible reaction, because here first of all nickel is heated and it turns into a new product, and then when the new product is when water is added in that new product, that is a yellow solid, it turns back to the green color. So this is clearly a reversible reaction. Let's see the options. A, combustion. It's not combustion because it's not corrosion, because there is no corrosion going on here. There is nothing breaking into particles. Neutralization not at all, because neutralization is always an acid-based reaction. But yes, here's the option, reversible reaction. That's it. D is the right answer. Different types of reactions are listed: oxidation, decomposition, combustion, reduction. The equation shows the reaction of magnesium with oxygen. Which types of reaction does magnesium undergo in this reaction? So first of all, we're going to look at this formula, the equation given. Mg plus O2 is equals to 2 MgO. So as we can see here, oxidation is going on, as there is an increase in oxidation number, and there is an addition of oxygen, so it's definitely oxidation. 1 is right. It's not decomposition, it's not breaking into smaller particles, it's done in the presence of oxygen, so it's not decomposition. It's combustion. Yes, it is combustion. And it's not reduction, because oxygen is being added, and then when we find out the oxidation number, so oxidation number is increasing, thus it's not reduction. So let's hear the options. The answer is 1 and 3, which is A. A is the right answer. Which colors are seen when litmus and methyl orange are added to separate samples of aqueous sodium hydroxide? So here we're gonna read the options. Which colors are seen when litmus and methyl orange is added to separate sample of sodium hydroxide? When litmus is added, so it is gonna be blue in color, and when methyl orange is added, so it's gonna be yellow in color. So because it's a base, so we are gonna see that the options: blue orange, not the right option. Blue yellow, yes, this is the right answer. When we look at the color changes that is usually given in your books, go through it once before going for exams, just the night before exams. Make sure these key points are revised. So it's gonna be blue color in base and red color when talking about acids, and same goes for methyl orange. It has different color changes. It is orange to yellow, that means acid to base. Its color changes, so it's gonna be B. 17. The positions of element W, X, Y, and Z in the periodic table are shown. Which elements form basic oxides? So we are gonna look at it. There's no need to use periodic table. We have the periodic table given in front of us. We must know the characteristics of each period and group when we are solving these sort of questions. These types of questions often appear in the paper, especially in MCQs. So W, which element makes a basic oxide? So yes, W is in group 1, so it makes a basic oxide. It definitely does. It's known as alkali metals. Group 1 are usually known as alkali metals. So W is the right answer to it. Then talking about X, once again, yes, it forms basic oxide as it is in group 2. if we talk about Y, so yes, it forms a basic oxide, whatever is over here. You can take help of the periodic table if you wish, because it's a metal, it will form basic oxide. But when we talk about Z, no, it won't form a basic oxide. It's from group 7, and group 7 usually do not make basic oxides. Make sure you're focusing on the word oxides. So it's gonna be W, X and Y, which is option number A. So A is the right answer. Coming to MCQ number 18, an acid is neutralized by adding an excess of an insoluble solid base. A soluble salt is formed. How is the pure salt obtained from the reaction mixture? So we're gonna go through the first option first of all. First of all, let's look at the key points in it. An acid is neutralized by adding an excess of insoluble solid base. The solid base is insoluble. A soluble salt is formed. This is from the salt chapter, and these things are usually learned by students and teachers. Explain it in the classrooms how to solve these sort of questions. So we're gonna quickly go through the options. How is the pure salt obtained from the reaction mixture? So here we have nothing to do with the neutralization and the insoluble solid base a lot. We are just going to tell how to get the soluble salt out of it. So we're not going to do crystallization first of all. Neither are we going to evaporate yet. So A cannot be the right answer. We're not going to do evaporation first, definitely. Yes, we're going to filter first. Then we're going to evaporate after the mixture, after the solution is out, and then we're going to do crystallization. So D is the right answer. Coming to MCQ number 19, a substance is tested with 3 different reagents. Which row shows the result obtained with the aqueous iron 2 nitrate? This is a bit of an ATP type question, but we'll go through it. Aqueous sodium hydroxide forms green precipitate. We're talking about iron 2 nitrate over here. So first of all, we're going to see at the cation, that is iron 2, and nitrate, the anion. According to the cation test, yes, it has green precipitate and it is insoluble in excess. You do these experiments usually in lab, and teachers probably, I think they have shown you how things turn out when they are reacted with these reagents. So I can't show you the experiment at the moment, but you must go to the lab and do these experiments if you haven't done it yet. So green precipitate, it does not form white precipitate, because it's why doesn't it form white precipitate? Because it's a transition element, and transition elements usually have colored solutions, colored things. They're colored, so make sure you choose the colored ones. So it's gonna be green precipitate and insoluble in excess, which is option A. Acidified aqueous silver nitrate. There's going to be no reaction. However, when we talk about acidified aqueous barium nitrate, once again there is no reaction. So the answer is simply A. Part of the periodic table is shown. Which row describes the properties of X, Y and Z? Good conductor of electricity, high melting point. So once again, this is a periodic table style question. So we're gonna go through the options and we're gonna go through all of it. So Y is a metal, so it's definitely a good conductor. And Z as well. It's a metal, it's transition metal, so it's definitely a good conductor of electricity. It's a property. High melting points. So X does not have a very high melting point, and it's not a metal, so it's not a very good conductor of electricity. High melting points, transition metals usually have high melting points, so it's gonna be Z. In high melting point, we're gonna go through the options. So once again, Y and Z are good conductor of electricity, and Z has a high melting point. So over here, X is a good conductor of electricity. No, that's not correct. But yes, this is correct, but still it's not the option. Y, Z and X, once again not an option. Y and Z, yes, that's the right option. So it's C. Thank you very much for watching the video. I hope it helped you out. I hope you found out the queries and you were able to make your concepts better. Make sure to subscribe my channel, hit the bell icon to be updated with the video as soon as I upload it. Like my video, share it with your friends, and keep studying hard. Make sure you comment down your queries in the comment box and I'll make sure I solve them.